Here's an example problem where you have to use the limit definition of continuity to solve. This problem is very difficult because you've never seen something like this. If someone gets this right, that's amazing, seriously. If you don't, that's okay. But what I want you to do is, take a couple minutes, write down the limit definition of continuity, try to solve this problem, and submit it as number 4. Okay, after a couple minutes, if you still can't get it using the limit definition of continuity, then write I have no idea, and we're gonna go over it. Okay, but this is really stretching you out here because I'm just throwing you into the deep end right away. It doesn't count, so please don't get mad. But I'm basically saying, can you figure this out based on this? So I'm giving you a formula and saying, use that to solve a problem. See if you can do it. If you can't, that's okay. That's kind of what separates great math students with good math students. Great math students can solve any problem, even if they've never seen it before. Not any problem, but a lot of problems, even without seeing them. Good ones just can solve problems after they've seen a teacher do it, and then they know how to do it, then they can do it. So it kind of, I don't know. You can still be a great math student if you're in one boat or the other, but I do want to eventually shift everyone into that great math student category of being able to solve problems even if you've never seen them before. First thing I'm going to do is write the limit definition of continuity down. All right, so first thing I said to do anytime you see it when it's a continuity problem like this is I would write down the limit definition of continuity. So we're going to do the limit of f of x as x approaches c, but it's actually approaching 2 in this one, so c is equal to 2 from the right side. And we're going to say this is equal to the limit as x approaches 2 from the left side, and then it needs to be equal to where it's exactly equal to 2. So both of them are approaching 2 from one side, from the other, and then right on at 2, at x equals 2. Okay. So from here, first thing I'm going to do is, just because I'm going left to right, is to figure this out right here. Okay. Well, this part, you have to think, what piece do you use? This is a piecewise function here. It's written very weirdly, but which piece can we use if we're approaching 2? Well, this one is if it's equal to 2. So you cannot use that f of 2 equals k. By the way, since f of 2 is equal to k here, I'm just going to write equals to k because that's equal to k. It says it right there. So while I'm there, might as well just throw that in there. All right, so there we go. So this part, we have to use the other piece, okay, which throws off my color coding. So hold on one second. All right, there we go. So this part is what we're going to need for this limit here. Now, there is only one piece, so I'm actually going to combine these. I mean, you don't have to do this, but it goes with what I was saying before. These two things are basically equal to where it's 2 on both sides. And we're going to try to figure out, if you plug in 2 to this function right here, what do you get? Can someone help me out with that? What?
That was the hard part.
That was the hard part. But if you directly substitute 2 in there, what do you get? 0 over 0. So a light bulb should be going off in your head. 0 over 0, that means there's an answer. I just need to figure out how to do that. So we actually did problems like this already, believe it or not. Let me just copy it down really quick. If there is a rational in there, what technique do we need to use to find the limit? The what? Conjugate? Oh yeah, conjugate. Yeah. It's called the rationalizing technique, but yeah, we need a conjugate for this. So what we're going to do is we're going to do the conjugate of the top. So instead of a minus, it's going to be a plus. Okay. And then we're going to divide this by the conjugate again. I wish there was a mathematical shortcut to using conjugates. There's one where you can have a bar over something like this, but you still had to write down the whole thing. So might as well just write down a minus b for the conjugate. I wish I didn't have to write all this out, but it's okay. Okay, so this is actually related to stuff in 112. Even though this is section 1.2, the previous section you also need to use this because you're still finding limits. Okay, the shortcut for finding conjugates, when you multiply conjugates together, is just the first one. Notice I'm writing LIM as x approaches 2, but you square the first one. So I'm squaring this thing right here. Okay, and then subtract it from this part right here squared. That's the top. And then I told you before, do not distribute unless you have to. So that bottom part, I am not going to distribute. Oh, this is a nightmare. Look at this. This is why I said it was like, it's borderline, I'm just being mean to you by giving you this problem, but it's good. It's a lot of learning in this problem, so it's okay. All right, let's simplify some things. X minus X here, or 2X minus X here is X. 5 minus 7 is 2, so now I have X minus 2. Let's use this orange. No, it's too close to what I just did. The X minus 2 and X minus 2 cancel to be 1 over 1. Now, if you notice, I got rid of what was causing the 0 over 0. This right here was causing the 0 over 0, the things that I'm highlighting. But they just canceled out. So now we can do what? What? Plug the 2 in, is that what you said? Yeah, okay, direct substitution, plug the 2 in, I love it. So now I just plug the 2 directly in, and you end up with 1 over the square root of 9 plus the square root of 9, which is 3 plus 3, which is 1/6. So, oh, by the way, I forgot, I got rid of that equal to k, so that's equal to k. That equals k comes down the whole time because it's equal to f of 2. I just remember I wrote it and then I undid it because of the highlighting, so I had to put that in there. Anyway, long story short, that's the answer.